Let's share the screen again. Yeah. So curvature in B, kappa we have related with moment by the equation m over ei. And this is also opposite of the radius of curvature. So this is your radius of curvature by simple definitions and geometry. And also you know that from our earlier definition, that kappa is equal to d theta by dx. So this theta is your angle of rotation. Dx is the distance, you know, if I take the cantilever beam, this is dx, I can define, it is a distance within the axis of the beam. Now again imagine a curve. How do I relate with the deflection now? Because and now I relate theta with, I mean the slope with the deflection. So this is your theta, this is your rad, this is your radius of curvature, and if this is the distance, the from here to here, let's say 0.1, मतलब आप जब आप आगे ट्रैवल करते हो तो यहाँ पे अगर मेरा डिफ्लेक्शन y है, y की जगह हम v यूज कर सकते हैं सिंबल. So when you travel from here to here, let's say डिफ्लेक्शन कर्व मेरा 0.1 है, m1 m2, तो यहाँ पे डिफ्लेक्शन v होगा, तो यहाँ पे हो सकता है डिफ्लेक्शन मेरा थोड़ा ज्यादा होगा. एंड हाउ मच इज द इंक्रीज v प्लस dv, थोड़ा बढ़ेगा, राइट. So from when you travel from here to here, the deflection happens, and from this end to this end, smaller differential length over the increase in the deflection is dv. But I can always write, if I take this, if this angle between this normal is d theta, then I can define that this deflected curve and the horizontal, जो परपेंडिकुलर और डिफ्लेक्टेड शेप के बीच का जो एंगल है वो अगर 90 डिग्री वो डी थीटा है दो पॉइंट के बीच में, then I can easily define that this angle is d theta.
गुड मॉर्निंग मैम.
अच्छा मिल गया, मैं ले लिया.
कॉपी
हाँ
सॉरी
हाँ हाँ
બધી કૂપન આપણે નથી આપીને.
हाँ
क्या नहीं આપી
ना ओके
અમને અઢાર કોન્ટેક્ટ ચેન્જ થશે.
ओके सॉरी. हाँ, so these can be d theta, right? If these two normals, and because this is the deflected shape and this is a horizontal, so horizontal and the deflected shape, this angle can be, so जो आप slope define करते हैं, you can write now sin theta, or approximately we can write theta, cos theta, approximately we can write, but this theta will be this side over this side. Okay, so I mean I can write tan theta as theta will be dv by dx. And you can write, of course, cos theta as dx by ds. That is about the this curve. जो आर्क लेंथ है, एक्चुअल आर्क लेंथ जो है वो ds है. तो अगर cos थीटा लिखना है तो ऐसा लिख सकते हैं, sin थीटा लिखना है तो dv by ds लिख सकते हैं. सो सिंपल ज्योमेट्रिकल डेफिनेशन. जैसे मैंने आपको कहा, दिस सबटेंडेड एंगल टर्न्स आउट टू बी d थीटा हियर. सो हम dv by dx थीटा करके हम स्मॉल एंगल करके लिख सकते हैं. Fine. So how do we relate this with our equation? So theta is now this, because this is the deflection and this is the horizontal length dx, which I am concerned with because we are having small deflection. We are having small deflection, so that I can always relate theta equal to dv by dx, where v is your deflection and dx is the horizontal flat distance जो हम मेजर करते हैं बीम के एक्सिस के मेजर करके. यू कैन ऑलवेज मेजर दिस. ओके, नाउ राइट दिस थीटा हियर, एंगल ऑफ रोटेशन. हमें एंगल ऑफ रोटेशन मिल गया इन टर्म्स ऑफ डिफ्लेक्शन. इट इज बेसिकली द स्लोप ऑफ द कर्व. तो स्लोप तो आपने कैलकुलस में सिखाई है आपके 12th स्टैंडर्ड में. स्लोप ऑफ द कर्व व्हाट इज दैट? dy by dx. यहाँ पे dy by dx के जगह हमने dv by dx लिखा है. डिफ्लेक्शन को y के जगह फंक्शन हम भी लिखेंगे. आप dy by dx भी लिख सकते हो. कई कई जगह पे y एज अ डिफ्लेक्शन भी लिखा होता है. सो नथिंग कंफ्यूजन. dv by dx is your slope, angle of rotation, slope of the curve, that is dv by dx. Now how do we relate this displacement and angle of rotation with this curvature? So curvature k kappa is equal to d theta by dx equal to 1 by rho, and also it is m over ei. So now replace theta with dv by dx. So ये theta भी कहाँ से आया? You should not have any confusion. It is a very simple geometrical interpretation here, that if this is your theta, small angle, then how much is the increase in the deflection? That is total. This is dv actually, and total is v plus dv. So dv by over dx. It's as simple as that. So we may write this in the form of this equation. So we replace now kappa is equal to d by dx dv by dx. This will be d square v by dx square is equal to m over ei or 1 by rho. So everything is related now. We have deflection. Okay, we have dv by d theta is your rotation also. So I may further write d theta by dx, the same equation. I relate angle of rotation, I relate deflection, I relate moment, I relate curvature, I relate radius of curvature. The picture is very clear in front of us. That moment is also related, moment and deflection. So mostly we will be using this formula to solve our problems, or we may use even because dv by dx is theta. जब theta ढूंढना है angle of rotation तो dv by dx हम use करेंगे. But what form? That again we have to write. So again external load is not relate. How do we relate now? Another relationship we need to establish. See, today's class is devoted to theory. Now next time we will solve examples based on this. So this is just a theory I wanted to tell you, and it is very fundamental and basic. So everybody should know these basics. Okay. क्योंकि आपको अंदर क्या चल रहा है वो ऐसा नहीं, बिल्कुल मालूम नहीं. हाँ, ऑफ कोर्स वी आर गोइंग टू यूज दिस फॉर्मूला, दैट इज एप्लीकेशन पार्ट. ये फॉर्मूला का क्या यूज है वो हम प्रॉब्लम सॉल्व करेंगे तब देखेंगे. बट टू अराइव एट दिस फॉर्मूला, हाउ डू वी रिलेट मोमेंट, डिफ्लेक्शन, रोटेशन, दैट यू शुड नो. Now, one more thing, that I also need to relate shear force, moment, loading, and then how do I relate? So for that, I think I will take back to the slide again. Okay. So just we need to establish the relationship between bending moment and the shear force. And then automatically we will be able to establish the deflection and the shear force, loading and the shear force that we will see. So in this diagram, you may see here that a free body diagram is being taken. मतलब कोई भी बीम है उसका हमने क्रॉस सेक्शन कट किया है. Any beam and I have cut two cross section, maybe M1, M2 आप उसको देख सकते हो. And then you have seen that non-uniform bending, always like bending moment diagrams are something like either these or something like, you know, these, whatever. So bending moment diagram, from you may see the moment is not same at all unless it is not uniform bending. I told you uniform bending is this, then moment diagram is this, every cross section moment is same. But otherwise, all other cases bending moment is non-uniform. So every cross section bending moment changes. That means there is a variation in the bending moment. So how do I write the variation? Variation in terms of calculus. जब भी कोई quantity vary होता है small amount में, means we take a very small strip dx, यहाँ पे small strip लिया है हमने dx, क्योंकि calculus use करना है, otherwise हम differential equation derive नहीं कर सकते. It will be a general formula, but आप डायरेक्ट फॉर्मूला लिखोगे तो आप कैलकुलस, it is not applicable to general, a very specific case you can apply that formula. So what is the purpose that you should understand why we are using calculus? What is the purpose? Because why we want to take the help of differentiation calculus, so that we can extend the concept to the more general applicable to any example, the same concept. Once we have governing differential equation, I can solve my problems. I can solve that equation, right? Mathematically or whatever. So we learn that technique, integration method also. Very simple technique. It is not very difficult. But you should know the application of differential equation even in structural analysis. Okay, so coming back to this point, dx is a very small length taken here, and I know that left side and right side the bending moment is not same. So how do I write the variation, increase in the moment, that is m plus dm. Left side में m है, अगर loading है ऊपर, and when I am traveling from this end to this end, there is a variation. Okay, so how much is the variation? Increase in the bending moment, small increase. Why small increase? Because small length. Right, so differential element and differential increase in the moment, that I am writing. And positive sign convention you have mentioned, like it is like this, tension in the bottom, और तो left side से आपको clockwise मिलेगा, right side से आपको anti clockwise मिलेगा, right? So यहाँ पे clockwise क्यों दिखाया है? Because it's the positive sign from the left side. यहाँ पे anti clockwise क्यों दिखाया है? Because it is the right side, anti clockwise. It's a positive, both pair are positive. Positive sign for the bending moment are pair of positive moments. Then shear force, of course there is a loading, so shear force भी change होगा. Shear force का भी diagram कभी ऐसा होता नहीं है. I mean sometimes you have the shear force diagram, even there is a variation, negative or positive or whatever. This may be the shear force diagram. So I have to show the variation over the shear force also. So how do I write? Again positive and negative. When you travel from this end to this end, here it is V. This is your shear force, but variation in the increase in the shear force change. Actually not increase, I would not say increase or decrease. Negative भी हो सकता है, positive भी. So change in the shear or change in the moment. I would not say increase. Change in the shear force or change in the moment. So V plus dV is the change in the shear force. Right? You can show arrow from left side upward positive. This pair of shear forces are positive. और उसके उल्टा होगा तो नेगेटिव होगा, राइट? ऐसा. दिस इज नेगेटिव शेयर. और नेगेटिव मोमेंट कैसा होगा? इस हिसाब से. तो यहाँ क्लॉकवाइज था तो उसकी जगह यहाँ एंटी क्लॉकवाइज हो जाएगा और यहाँ पे क्लॉकवाइज हो जाएगा. दिस इज योर नेगेटिव मोमेंट. But here positive sign conventions are shown. So from left shear force upward is positive, from right shear force downward is also positive. Pair of shear forces are positive, whatever sign convention shown over here. Okay, now we take the differential equation, I mean moment equilibrium equation. So considering moment equilibrium equation, and also we will take the force equilibrium, that is sigma Fy 0 and here sigma m 0. This is a free body diagram and we take the moment equilibrium equation, summation of all moments at this point, let's say at this junction, right hand side, उसके ऊपर हमें मोमेंट लेंगे. तो अगर क्लॉकवाइज पॉजिटिव कंसीडर करते हैं देन द मोमेंट इक्वेशन बिकम्स जो फोर्सेस से मोमेंट क्रिएट हो रही है विथ रिस्पेक्ट टू विच पॉइंट, राइट हैंड साइड पॉइंट O. Let's say origin O or whatever. We are taking moment with respect to let's say अगर सेंटर में है O तो origin के हिसाब से हम मोमेंट लेंगे. So clockwise positive तो M, okay, M, this is M, clockwise positive. Then V into dx will also give you clockwise moment. So V into dx is also clockwise moment. Then Q. Okay, then even at this point there is a moment, so it is in anti-clockwise, so minus m minus dm, क्योंकि एंटी क्लॉकवाइज में हम जब इक्विलिब्रियम इक्वेशन लिखते हैं तब एक ही साइन कन्वेंशन फॉलो करना है, बट जब हम लेफ्ट और राइट करते हैं तो ये पॉजिटिव है, पूरी साइन कन्वेंशन पॉजिटिव है. व्हेन यू आर टेकिंग सेक्शन दैट टाइम योर साइन कन्वेंशन मे बी in this case though it is anti-clockwise it is positive moment, okay, but when you are writing equilibrium equation you have to follow one consistent sign convention, that is clockwise positive, and that is the reason we have written anti-clockwise negative moment here, that is minus m minus dm. This is anti-clockwise, so I have written minus m minus dm plus और माइनस whatever. लोडिंग के वजह से मोमेंट कब कैसे क्रिएट होगी? मोमेंट, दिस लोडिंग विल क्रिएट मोमेंट अबाउट दिस पॉइंट ऑन द राइट हैंड साइड एंटी क्लॉकवाइज डायरेक्शन. So again it is negative. So negative is minus q into how much is the distance? Dx is a force and the moment will be dx by 2. हाफ मतलब सेंट्रोइड जो आपका है वो डिस्टेंस से आपको मोमेंट लगेगी. So dx by 2. So actually it is q into dx. It is a load, uniform load. तो हमने dx से मल्टीप्लाई किया, मल्टीप्लाई बाय dx by 2. So this is your moment anti-clockwise due to loading, uniform loading. So complete equation and right hand side equal to 0 because this force won't produce any moment because वो पॉइंट पे ही एक हो रहा है तो वो फोर्स कभी भी मोमेंट प्रोड्यूस नहीं कर सकता है. v plus dv will not produce any moment. Why? Because कोई फोर्स है यहाँ पे, ठीक है, और I mean there is no distance, so at if this is a force, this force will never create any moment at this point. There is no distance available, right? There is no perpendicular distance available for this particular force, that is v plus dv. So what we do, total moment equilibrium equation is written this way and then we simplify. तो सिंप्लीफाई में क्या करना है? यू गेट लाइक दिस गेट्स कैंसल, ये m और m निकल जाएगा. फिर दिस इज अ वेरी स्मॉल क्वांटिटी बिकॉज dx ऑलरेडी स्मॉल, dx square is even further small, less than unity, right? Always. So smaller and smaller, so let us discard. And then final equation, what it becomes? V dx. I am writing here on top V dx minus dm is equal to 0. So I can simply now write simplified version dm by dx equal to v. So we have arrived at another differential equation. Derivative of moment with respect to x gives you shear force. तो अगर आपको कोई मोमेंट का एक्सप्रेशन लिखा है तो x के फॉर्म में, अगर मोमेंट बेंडिंग मोमेंट का जो एक्सप्रेशन है वो हम करने वाले हैं x के फॉर्म में, आपको लिखना आना चाहिए बिकॉज वी आर यूजिंग डिफरेंशियल इक्वेशन. सो हमें इंटीग्रेट करना पड़ेगा, डिफरेंशिएट करना पड़ेगा, राइट. सो वी नीड टू एक्सप्रेस द मोमेंट इन टर्म्स ऑफ x. सो x का सिर्फ डिस्टेंस फिर आपको वहां पे डालना है to get the bending moment at any distance x within the beam. Okay, so first we have to write the expression moment in terms of x. That is the next class we will see solve example. We will practice for writing bending moment equation in terms of x within the beam. We take the specific case of simple support, cantilever, all those things, and when I differentiate that, then I get shear force. Okay, so this differential equation is also very helpful. So this is first order dm by dx. That one earlier was one second order. जो हमें deflection के साथ whatever equations we have obtained, just a second. हाँ, हाँ. So here you may see it was second order, right? This is second order. Whereas अभी जो हमने derive किया dm by dx equal to v, this is first order, but it relates moment with shear force. This relates deflection with moment. Now we'll see how loading is also being related. So let us see. So force equilibrium लेते हैं. So vertical forces, so though no moments, only vertical forces, summation of all forces in y direction. So just take V, this is your V, sorry. This is your V, vertical force positive. Let us take force, vertical force positive, V. ये downward लग रहा है, so Q into dx. Then this is downward again, so minus V minus dV. A very simple equilibrium equation I have written. जब आप, again I am repeating, see these are positive shears, I know, pair of shear forces, but when you write equilibrium equation, you have to follow consistently one single sign, that is all vertical forces are positive, all downward forces are negative. And that is the reason somebody should not ask me why this is not positive. It has to be negative. Why? We are taking the equilibrium of the entire body. Okay, whole body, means not just by parts. Entire equilibrium of this body will be V minus V upward force positive minus Q into dx downward force, then this downward force again, so minus V minus d equal to 0. So if we simplify, this V and V cancels, and then I have equation Q dx is equal to dV. So I can write dV by dx is equal to Q. So what is dV by dx? It is the derivative of shear force with respect to x will give you the loading. Okay, so we have been establishing the relation between bending moment and shear force and loading. So 4 equation we have seen. Now I will switch over to the board again. Okay, so what we have seen so far, we have been able to establish 2 relations. First, of course, d theta is equal to dv by dx. Then we have d theta by dx is equal to 1 by rho or kappa is equal to m over ei. So curvature and the moment theta, derivative of theta is your curvature, then slope, so derivative of deflection with respect to x. You may again switch back to this if you want to see. And then when you replace this theta here, you get d square v by dx square is equal to minus m over a. So I told you this is moment, this is deflection. Okay, and now we have another relationship, that is dm by dx equal to v. So this is moment, this is shear, and we have another relationship, that is dv by dx equal to, it was minus q. So negative sign is downward loading. So this is loading and this is shear. Okay, now I told you this is second order. डिफरेंशियल इक्वेशन, इसको हम डिफरेंशियल इक्वेशन बोलेंगे. सो पूरी जो जर्नी है, हम कहां से कहां पहुंचे. पहले हमने स्ट्रेन कर्वेचर रिलेशन डाला, फिर हम स्ट्रेसिस को लाए, देन फिर हमने स्ट्रेसिस को मोमेंट से रिप्लेस किया, एंड देन वी ट्राई टू रिलेट मोमेंट अगेन विथ कर्वेचर एंड द rotations, derivative of the rotations. So curvature is what? Derivative of the rotation with respect to x, that is curvature. And then we again relate deflection with the angle of rotation, the slope. And we are trying to, with these two alone, we are able to derive our second order governing differential equation, but that in terms of moment. So now I want to bring in terms of loading, in terms of shear. So how do I do? I write moment in this equation. So from equation 1, we write substitute moment in equation 2. So स्लाइटली सिंप्लीफाइड करो उसको. मोमेंट कैसे लिखना है? EI इंटू डी स्क्वायर वी बाई डी एक्स स्क्वायर. इस ये सेम इक्वेशन को m को लेफ्ट साइड में रखो, ये EI मल्टीप्लाई कर दो एंड डी स्क्वायर बाई वी बाई डी एक्स स्क्वायर, एंड यू रिप्लेस मोमेंट इन दिस इक्वेशन. सो डी बाई डी एक्स इंटू मोमेंट के जगह हम लिखेंगे EI डी स्क्वायर वी बाई डी एक्स स्क्वायर इज इक्वल टू shear force. So अगर आप सिंप्लीफाई करते हो तो d क्यूब v बाई डी एक्स क्यूब इज इक्वल टू v. तो हमें थर्ड ऑर्डर डिफरेंशियल इक्वेशन, वो क्यों किसको रिलेट करता है? shear एंड द डिफ्लेक्शन. तो मोमेंट निकल गया वहां से, shear एंड डिफ्लेक्शन. सो कौन सी क्वांटिटी मुझे यूज करनी है, दैट डिपेंड्स ऑन द प्रॉब्लम्स. एग्जांपल्स हम सॉल्व करेंगे कि कहाँ पे ये थर्ड ऑर्डर कहाँ पे यूज होता है, सेकंड ऑर्डर कहाँ पे यूज करना है. जब मेरे पास shear force का एक्सप्रेशन है, देन आई विल बी यूजिंग थर्ड ऑर्डर टू कैलकुलेट द डिफ्लेक्शन. व्हेन आई एम हैविंग सेकंड ऑर्डर मोमेंट का एक्सप्रेशन है, देन आई विल बी यूजिंग सेकंड ऑर्डर डिफरेंशियल इक्वेशन टू कैलकुलेट द डिफ्लेक्शन, राइट? सो डिपेंड्स ऑन द स्पेसिफिक केस, बट this relationship you should know. Okay, now I can always write the v, that is equation 3, in equation 4. So shear force with the loading का इक्वेशन तो है ही. अभी हमें डिफ्लेक्शन और लोडिंग का इक्वेशन यूज करना है. डिफ्लेक्शन और shear आ गया, डिफ्लेक्शन और मोमेंट आ गया, ठीक है. एंड देन फर्स्ट डेरिवेटिव इज ऑलवेज, फर्स्ट डेरिवेटिव dv by dx अगर होगा वो ऑलवेज रोटेशन होगा, दैट वी ऑलरेडी नो राइट फ्रॉम दिस. सो दिस इज अ फंडामेंटल इक्वेशन, फर्स्ट ऑर्डर. ये फर्स्ट ऑर्डर है, ये वाला सेकंड ऑर्डर है. फर्स्ट ऑर्डर में सिर्फ थीटा और डिफ्लेक्शन रिलेट होते हैं, सेकंड ऑर्डर में मोमेंट और डिफ्लेक्शन रिलेट होता है. थर्ड ऑर्डर वी हैव shear force एंड द डिफ्लेक्शन, एंड नाउ वी रिलेट एंड देन फर्स्ट ऑर्डर also with moment and shear. First order also with shear force and the loading. And that is a simple formula, right? We have just now derived that formula. You can just browse through it. I will share this PPT to you and you may just revise that. Okay, I will share these slides to you, all of you. कि ये इक्विलिब्रियम इक्वेशन जो रिलेशनशिप है वो कहाँ से आया? सिंपल इक्विलिब्रियम इक्वेशन है, फ्री बॉडी डायग्राम है. हमने सिर्फ समेशन ऑफ ऑल फोर्सेस इन मोमेंट एंड समेशन ऑफ फोर्सेस इन वाई डायरेक्शन लिया है एंड देन वी आर एबल टू रिलेट डिराइव दिस इक्वेशंस. सो देयर इज nothing difficult in this, very straightforward. Okay, now as I told you, I can also bring equation 3. If I substitute here, I can bring the fourth order differential equation in terms of loading. Okay, so let us write dv by dx. So v के जगह हम लिखेंगे ये equation. So substituting equation 3 into 4. So d cube v by dx cube is equal to minus q. So this is d to the power, अभी simplify कर, so d to the power 4, so fourth order differential equation in terms of deflection. So we are getting this deflection and the loading. So हमें क्या चाहिए? वही चाहिए, हमें shear force ढूंढना है, moment ढूंढना है, deflection rotation ढूंढना है. We will be using all these 4 equations. So our job is done here. And we use this, and frequently these equations are, there are a couple of more methods, 2-3 methods where एक इंटीग्रेशन मेथड में ये यूज होने वाला है, दूसरा हम कंजुगेट बीम मेथड भी यूज करने वाले, जिसके अंदर भी ये फॉर्मूला यूज हो गए. सो इट वाज नेसेसरी फॉर मी टू गिव यू दिस बैकग्राउंड. ओके, यू शुड नो दिस थियरी. दिस इज कॉल्ड एज थियरी ऑफ बेंडिंग. इट इज बीइंग डेवलप्ड बाय द पर्सन नेम Bernoulli and Euler. So if you write in Google or you search in Google Euler Bernoulli, I think Bernoulli spelling is different. I need to check. Is the name from the person? NOU. हाँ, double L I. हाँ, I think spelling is correct. Euler. This is called Euler Bernoulli beam theory. This is also called a theory of bending. So basically we need to see how we can use these formulas. Okay, so I will summarize this formula again. I think last slide was that. So differential equation of deflection. So this is a second order. This is a second order differential equation in terms of moment and deflection is there. Then we have this shear force cubic variation. So we have derived this, right? How that cubic variation comes. Third order and then fourth order. Okay, so these 3 to 4 equations, these 4 equations particularly, and also theta dv by dx, theta equal to angle of rotation equation. These 4-5 equations we'll be frequently using. These 4 equations are very useful. So this is a summary. I think so this is a summary. You can see here the formula. Just keep in mind this equation whenever I ask, you should know this. Theta is a derivative of deflection. Then second order deflection is a moment relation. D square y by v by dx square is equal to m over ei. Then first order with shear and moment and shear and loading. This is also important. So in summary, we have seen, I will write the formula here. Theta is equal to d by dx. Then d square v by dx square equal to m over ei. also like kappa or d theta by dx is equal to 1 by rho. Then also we have d square d cube v by dx cube equal to shear force. Then d to the power 4 v by dx to the power 4 is equal to minus q loading. And then we have dm by dx equal to v. And then we have dv by dx equal to minus q. So all these formula are going to be useful. dv by dx minus q. Okay. So this is a summary of whatever we have learned. So next class we will, I think I will stop today's class. Next class we will see how to use this formula. But you know when you are dealing with second order, तो आपको जब ये डिफ्लेक्शन ढूंढना है तो आपको इंटीग्रेट करना पड़ेगा, तो उसको इंटीग्रेशन मेथड बोलेंगे. बट आप अगर इंटीग्रेट करते हो सपोज dv by dx है and some function, okay, then when I integrate to get dv v into dx, then dx that variable will come, right? So I have to write my v or whatever function y, I have to express in terms of x, right? Then only I can integrate. तो लॉजिकली हमें अगर सेकेंड ऑर्डर डिफरेंशियल इक्वेशन यूज करना है टू सॉल्व आवर प्रॉब्लम, आई विल इंटीग्रेट दिस ट्वाइस. ठीक है, एम ओवर ई आई. तो अगर डिफ्लेक्शन ढूंढना है उसमें से, देन आई विल इंटीग्रेट दिस ट्वाइस एम ओवर ई आई. फर्स्ट इंटीग्रेशन एंड सेकेंड इंटीग्रेशन एक बाय एक, वन बाय वन करोगे विद सम कॉन्स्टेंट्स विल कम इनटू पिक्चर. सो दिस टाइप ऑफ थिंग वी विल डू. देन dx अगर है इंटीग्रेशन का जो जिससे हमें इंटीग्रेट करना है, आई हैव टू राइट मोमेंट इन टर्म्स ऑफ x, देन ओनली आई विल बी एबल टू इंटीग्रेट. So next class our first job is to express how to express moment in terms of any distance x. Rather that formula will be very useful even for calculating bending moment and shear force diagrams. क्योंकि आप कोई भी distance x डाल के आप वो कैलकुलेट कर सकते, नहीं कि आपको सिर्फ 3 मीटर पे या 4 मीटर पे कैलकुलेट करना है मोमेंट, जो आपने स्ट्रेंथ ऑफ मटेरियल में किया होगा, दैट आई एम श्योर. So you may revise that also, but here we will again revisit how to express moment in terms of x. Then only I'll be able to use this formula to integrate and get my deflections and the rotation. Okay, so I think I will end this meeting today. Any questions?